Hello, welcome back to Father-Offspring Interviews, episode 11. So before we start, I just wanted to say Happy Mother's Day to all the mothers out there, especially to the matriarch of the Sapolsky family. There's been a number of requests for an appearance by my mom, who it has been scientifically proven is the greatest mom in the world. She tends to prefer being behind the scenes, but I convinced her to make a brief appearance here in honor of Mother's Day.
Hi, everyone. Just popping in to say thanks for your interest and support. We're pretty fond of science around here, so it's been great getting to see all your cool questions. Enjoy the episode, and you too, have fun.
Okay, well, here we are. Just as a public service announcement, do not share earwax with someone unless you know and trust and love them deeply.
And have children with them.
And have children with them. Okay, so we are here. I'm delighted we had this guest appearance.
On that note, we're gonna get to it. So Ross from Wyoming asks, does the new finding discussed in Sabine Hossenfelder's video on microtubules add any insight into how the brain can use quantal effects? And just so you all know, that is linked below if you want to check that video out.
Sabine Hossenfelder is the greatest. We love her in this house. She is this mad, eccentric physicist who has this fantastic YouTube video up explaining why there is no free will. And she does it in one of the most charmingly no-nonsense ways you can imagine. So, quantum effects, free will, new paper. All right, so quantum mechanics. When you get way out to the subparticle, tiny world, all sorts of stuff about causality goes out the window. Things are everywhere at once, or statistically distributed clouds. They can entangle with things at a distance in no time at all sorts of things. I should point out I have no idea what I'm saying right now because I really don't understand this stuff. But the second quantum indeterminacy hit on the scene, there was this immediate belief that this was going to explain free will. Somehow quantum freedom was going to explain it. And I tend to pull my hair out about this, at least three reasons why quantum indeterminacy is not where you get the imaginary state of having free will. First off, it is teensy, tiny little subatomic stuff and in unimaginably large number of levels of orders of magnitude. These effects would have to bubble up in wet, moist, warm brain tissue, which is exactly the type of environment where quantal entanglement falls apart, collapses. So there's no way it's going to go up to the level of affecting like one neuron, let alone your brain. Second problem, even if it did, what you've just come up with is a mechanism for producing random behavior. The whole point of quantum indeterminacy is it's indeterminate. We are not trying to explain whether you have free will when you've got some random behavior. You're trying to explain why your moral compass has been what it's been since you were 3 years old. You're not getting that with the randomness of quantal effects. The third one is, in a real Hail Mary move, a bunch of people have speculated that somehow you could reach down and harness your quantum indeterminacy and somehow corral that into being free will, and that makes very little sense at all. So amid this backdrop, there's been this theory that's been floated around by a couple of these, like, quantum free will zealots, Roger Penrose, who's a physicist, and Stuart Hameroff, who's an anesthesiologist, and they hooked up together and they came up with what I thought was a fairly nutty, unconvincing idea. And all of that was made much more uncomfortable for me when, like, Penrose was given the Nobel Prize not for this theory, but for his prior work in physics. But nonetheless, they had this notion that, yes, somehow quantum effects way down, 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 down at the subatomic level is not only our route to free will, but our route to consciousness. And the way it happened, according to them, is these eensy little things inside neurons. Okay, you got your neurons and they've got their projections and all of that. And inside neuronal projections, axonal, dendritic, all of that, are these little tubes, microtubules, microfilaments, this whole little world of stuff being transported up and down from one end of the neuron to the other along your microtubules. And I will admit that for me, they've never been the most exciting part of the neuron. They're essentially like little conveyor belts, and there are colleagues of mine who've spent their careers showing what's amazing about them. But, you know, they're shuttling like new mitochondria down to your axon terminals and then shuttling smelly old rusty ones back to be broken down and things of that sort. So the thing of microtubules is you got a long, narrow projection cable there. So you've got all these microtubules going in parallel, and they're understood down to every single molecule that forms them. And the notion was something about their parallelism. And here I'm getting on very thin ground, showing that I don't really understand what Penrose and Hameroff didn't understand about microtubules. But somehow the parallelism was an ideal environment for quantum effects, cross-linking and tangling of these microtubules, and somehow this was an amplifier, and out the other end came consciousness and free will. Hossenfelder does a pretty good dismissive job of saying that ain't where consciousness could possibly be coming from. I am completely frightened by the subject of consciousness and how it's neurobiologically done, so I'm just content to say that's sure not where you're going to get free will from. But this new study, which is referenced in the question, and which Hossenfelder's already had a whole short YouTube about it, is a paper talking about super radiance. I don't understand what I've just said, and how that in a quantum way can amplify light emission. And I don't understand what I just said about that either. And somehow that explains consciousness, and it's made very puzzling to me by the fact that insofar it appears to be about light emission, these microtubules are inside a cell, inside your brain, inside your skull, under your hair. So I'm not sure how much light is playing a role in that. But in either case, she presents their new theory that this is a way to somehow amplify quantum effects. And I, in my profound ignorance, am still deeply unconvinced that this is a way to get quantum effects synchronized, yoked together enough to bubble up and not disentangle in the wetness of the brain. And even if it did, you still got that randomness problem, and you still get that problem that every theory for how you can overcome the randomness and use quantum effects for your pleasure and advancement and free will and such makes no sense either. So I'm delighted to see that she not so politely reached the same conclusion.
Okay, well, to sort of continue on this theme, sorry, consciousness is a scary topic, but Richard from Virginia asks, well, so how does your position on free will inform your definition of consciousness? If we're not consciously making free will decisions, since we have no free will, where does that leave consciousness?
Well, to put my cards on the table again, I'm afraid of consciousness because I don't understand it. It just seems too puzzling to me. And every 10 years, I force myself to read a review paper on what the neurobiology of consciousness people are up to. And each time I come away even more confused, and which is convenient because consciousness is totally irrelevant to the free will question. There was this landmark, earth-shatteringly interesting experiment in the 1950s. This guy, Benjamin Libet, everyone who talks about free will has to talk about the Libet experiment by the second paragraph or so. This was one where subjects were being told to press a button anytime they wanted to, and you were able to tell from their muscles exactly when they had committed to making this movement, and they had these EEG leads, these electroencephalogram leads put on their heads where you could pick up a particular wavelength which indicated intentionality to begin this movement. And subjects were looking at a clock with a big second hand sweeping around, and we're told the second you become, the instant, the subsecond you become aware of your intent to push the button, look at the clock and remember what time it is. And the finding that came out of that was, about 200 milliseconds before people started moving their muscle and picking up the muscle tension, they became aware I was going to do that, so that's just fine. But whoa, 500 milliseconds or so before you first consciously became aware of your intent to do so, you could already pick up this brainwave pattern. And your brain knew before you did, is what everybody concluded from that. And subsequent work eventually using functional brain imaging, even single cell recording from neurons showed like 10 seconds before you could tell that the brain is already, conscious intent is just an afterthought. Your brain is so people have been fighting over that one for 50 years ever since then. Has there been enough time? Not quite enough time, but by the 50th anniversary, they'll still be fighting about it, because they're fighting over whether you are first having an intent or first aware of having an intent, and is there a difference between an urge to do something and the intent to do something. And for my money, this is totally irrelevant to the free will question, as is consciousness, because none of these arguments, none of these debates about this get at the most fundamental question, which is, okay, you're intentful at that moment. You have formed this intent. You're conscious of the intent. You know that if you start moving your finger, what the likely outcome is going to be. And most of all, you know, you don't have to push the button. You could be doing something else. You're not being coerced. And for lots of folks, that's necessary and sufficient for free will, mediated by conscious awareness of intent. And it means nothing whatsoever, in my view, because you only can make sense of that after asking the question, how did you become the sort of person who would have that intent? Like, how did everything from a second ago to back when you were like a fertilized egg and everything in between wind up producing you as the sort of person who at that moment would be pressing that button? And I don't mean just how biology, over which you had no control, and its interactions with environment over which you had no control, turned you into somebody who would push the button right then. How do you wind up being somebody who could read, go to university? How do you wind up being somebody who is interested in psychology and, be curious and altruistic and sign up for doing one of these psych experiments? How do you get the frontal cortical function so you signed up for a time and actually showed up that day instead of forgetting about it? How do you sat down and you didn't wind up with a personality where you were so intent on proving you were smarter than the psychologist that whenever you intended to do something, you made sure you did just the opposite to screw them up? How do you wind up being the sort of person that you came into the lab there and you saw they were just busy finishing up with the previous test subjects? Why didn't you just steal the grad student's computer and run out of there? How do you wind up being the sort of person so you would sit there and press that button? And when you look at all of that, whether you were conscious of that intent or otherwise, it makes no difference, because who you turned out to be in that instant was an end product of everything that came before that you had no control over. And consciousness is irrelevant. You can take a realm in which people really are comfortable with, there's much less free will there than you would think. You walk into an ice cream store, and unbeknownst to you, the wall there is painted this beautiful scene of the ocean and all of that, and you're not even aware of looking at it. But as a result of coming in there and that painting being there, you are now much more likely to order horseshoe crab ice cream. And you never even knew that was the reason why you did it. Wow, you were not showing free will because you were being unconscious, you were being subliminally manipulated and you weren't aware of it. Yeah, you're aware of it. You walk in there and you say, wow, I am really craving Cherry Garcia. I've just given up my San Francisco cred. Cherry Garcia, and here's why. Here's why, because of my association with it. Here's how I turned out to be the sort of person who would consider my options at that point and realize there was not a gun at my head forcing me to get this ice cream, and very intentfully coming up with that intent. And the whole thing about why free will has nothing to do with that conscious intent stuff is you could not have turned out to be someone who intended to intend something different from what you did intend. So consciousness is as irrelevant to acting with free will and our lack thereof as walking in there and like ordering mantis shrimp ice cream with like cherries on top. Irrelevant in either case. So I mostly feel free now to go another decade without trying to understand what people are figuring out about consciousness.
Okay, so Adam from London asks, if we were to go back in time and the Big Bang happened again, would I still have been born?
Adam, probably not. Probably not. And what we're getting at here is this distinction between the world being a deterministic one and the world being a predeterministic one. Predeterminism, 3 seconds, 3 gazillionths of a second after the Big Bang, everything was already set. Every event that was ever going to occur, every particle in the universe's interactions were already mappable out there. The future is already determined. And in this view, Adam, not only would you have been born just when you were born, but you'd be wearing the same socks today that you're wearing, everything else. The future is already set. That's not what biologically based lack of free will is about in the slightest. For a very simple reason, there's all this stuff out there that does in the reductive picture of predeterministic interactions of component parts in a way that's completely predictable for the rest of time. Chaos theory, chaoticism of systems, non-linearity, 3-body problems which produce things that are formally unpredictable. The future is unpredictable because somewhere a gazillion decimal places out, there's going to be a little hiccup of a difference. And because of the butterfly effect, sensitive dependence on initial conditions, something unpredictable will happen. And as soon as you think you have studied the world up to a gazillion decimal places out, and you know exactly how everything works, a gazillion decimal places but 1 plus 1 out there is where things may go off the predictability rail. So it's this seemingly, but not so, very paradoxical thing that this is a world without free will running on determinism, yet at this moment in the present, the future has multiple possibilities to it. It is only once all the indeterministic elements have played out that you could see in retrospect why that particular outcome could not have been controlled. There was no free will, that sort of thing. But the conclusion is, it was not all set in place right after the Big Bang. And separate of the relevance of that to whether or not any of us would have been born, this is very relevant in the larger sense of there's no free will. What that does not mean is, oh, everything is already determined, nothing can change. Don't bother trying to change something. And that is a universe away from what the absence of free will in a biologically deterministic world looks like. Everything can change. So this doesn't give you like means to sign off and say, this is hopeless.
All right, so finally, Maxi from Austria asks, what is your current best understanding of the biological origins of autism, especially what are the neurological differences to normal brains?
Autism, a neurodevelopmental disorder where you get differences in sociality, capacity for interest in, you get differences in all sorts of aspects of cognition, endless fights. Does autism and cognitive impairment go hand in hand? Absolutely not. Does autism and impaired capacity for empathy or theory of mind go hand in hand? Absolutely not. Does autism and, oh, those people never feel lonely, go hand in hand? Absolutely not in the slightest. It is a wildly complicated disease. It is, by best estimates, extremely heterogeneous in causes. It's not just one disease. What are some of the hints out there these days? One has to do with the sociality, the either inability to form close relationships or problems mastering the social rules of them and such. And there's some hints that that has something to do with this neurotransmitter slash hormone called vasopressin, along with its twin sibling hormone oxytocin. The two of them are very involved in mother-infant bonding, pair bonding, trust, reading facial expressions, things of that sort. So much more interesting than that. But first hints that in some families with a strong genetic load of autism, a few have been identified where there's mutations in the gene for one of these hormones or coding for the receptor for one of these hormones. So that's a piece of it. Then there's the whole cognition end of things, and something that is fascinating is a certain aspect of brain development does not consist of making more neurons and making more synapses, but instead having more of them than you are going to have as an adult. Having a surplus, and then you start this process of pruning away the surplus connections, running this wiring competition where the better connected neurons sort of last and the better connected connections last, and the other ones are pruned away. And people know a ton by now about how that pruning works, and it's fascinating. What are you doing there? You are making for a meaner, leaner brain at some point where you are getting rid of the fat in your synaptic circuitry there. The brain early in life, the brain right around adolescence, in different domains, different parts of the brain, is going to have more synapses than it will have as an adult because you're pruning away. And there's some evidence, and I find it convincing, that even at around the time of birth, some of that pruning in the cortex of individuals destined for an autism diagnosis has been a bit underactive. There is overgrowth in the cortex. There's less pruning than is typically the case. Implications of that, who knows, but that's out in the literature. And there's even been one growth factor, something called BDNF, brain-derived neurotrophic factor, that's been implicated in that. And so that's a piece of it. Third piece I love, I torture my students going on about this because it is so interesting. Power law distributions is this whole mathematical thing that describes why the world is full of examples of the 80-20 rule. 20% of customers comprise 80% of the people complaining and bringing back their whatever's wanting a refund. 20% of criminals account for 80% of all the crimes. 20%, this distribution where you mostly get a local cluster of most things being attributable to a small subset of elements, and then you get rarer ones that become increasingly rare at a distance. So all sorts of stuff shows power law. I won't go into that. Your brain, your cortex, shows a power law distribution. Cortical neurons sitting there in the cortex, how far away is the neuron that they're talking to? This neuron is sending projections all over the place. What's the average? What's the distribution of how far away are the neurons that this one's talking to? And you can have very local communication, or you can have crazy long distance ones that will go from your hemisphere on one side of your brain across this bridge called the corpus callosum to the hemisphere on the other side. Those are the longest projections. What's the distribution of those like? They show a power law distribution. Like 80% of cortical projections are within a local neighborhood, And then increasingly rare, you have long distance ones. What's this great for? This optimizes two things you want to do with your nervous system: to be really good and efficient and fast at solving familiar problems. And for that, you need a little local, highly interconnected node that knows how to do its thing. But you also need to be able to solve the occasional things that come up from out of nowhere, where you're going to have to come up with something entirely new. And if you're not talking to the folks 14 counties away and just going with the usual old routine, you are screwed. And a whole lot of cool stuff about brain development is coming up with an optimal 80-20 split between robust, resilient to injury local clusters that solve familiar problems with long-distance communication. So amid that, a really interesting finding, which in the brains of individuals with autism, there is a leftward slant, a leftward skew in the power law distribution. What am I saying? A larger percentage of the projections are very local ones, and there's fewer long distance ones. What does that produce? Isolated islands of really adept cognitive function. And this is getting us into the world of autistic savants and things like that. A brain that has very well functioning isolated islands of computational stuff, but nonetheless not as good as the average brain at integrating holistic sort of things, which in a lot of ways describes some of the cognitive strengths and weaknesses of individuals with autism. Two things to say here at this point. The first one, okay, so a pathology of like, ooh, there's something wrong with your cortical projections. This guy at Oxford or Cambridge, I can never tell them apart, some Brit guy named Simon Baron-Cohen. Yes, cousin of Sacha Baron Cohen, the actor. They must have some amazing Thanksgiving dinners, except they don't have Thanksgiving in Britain. But Simon Baron Cohen has long had this theory about what's going on with autism, built around a very interesting finding, which is on the average, male brains have a power law distribution skewing to the left compared to female. Male brains have fewer long distance projections from cortical neurons than do female brains. One consequence, that bridge I just mentioned, the corpus callosum, where you go in the really long distance ones, on the average is thinner and or less densely packed in male brains than female brains. So, okay, you see like a classic stereotype difference. Men on the average are better at like isolated and analytical cognitive processes. Women are better at integrative holistic ones. And you see a skewing that is reliably there. So in female-male differences, you see in that direction of the skewed brain of people with autism. So on this spectrum, on this scale of something that's like a normal sex difference thing, that's simply exaggerated there. Second thing to sort of as a take-home message here is these days, autism is not called autism. It is called as a part of ASD, autism spectrum disorder, milder version Asperger's syndrome. Spectrum. It's on a continuum. And thus we get back to the word normal versus the word normal in quotes. On a continuum, our sexual orientation is on a continuum, our sexual identity, the notion of the brain being cleanly binary in any way has gone to, everything's on a continuum, and mild versions of autism spectrum disorder are indistinguishable from what we would view as somebody with a quirky personality of a particular type, and all of that. Where the boundaries on these continuum, where the boundaries are drawn, are utterly arbitrary, laden with all sorts of historical miseries of people deciding some arbitrary boundary is not really arbitrary, all of that. So it's on a continuum. It's just a different way in which brains turn out to be at times. Final point, third of my last 2 points, is it is complete raving crap if anyone tries to tell you that vaccines have anything to do with causing autism. It is appalling, the damage that that pseudoscience, that medieval garbage has caused. So that's what I think about that.
Okay, that is it for episode 11. Keep submitting questions at the forum found in the Instagram story highlight and bio or the YouTube video description. I'm Offspring Sapolsky, and thank you for your continued support of Science and the Beard.